আছে সেই চারটে কোথায়?
আমার কাছে একটা
হ্যাঁ এই চারটে প্রশ্ন কি কি?
एलियन कॉन्सेप्ट
एलियन कॉन्सेप्ट
मैम मैं लिख के दे रहा हूँ.
हाँ बोलो एलियन कॉन्सेप्ट खाली ये बेसिक बोलो.
एलियन कॉन्सेप्ट
বলো।
Hello everybody, good evening to all of you. Hope some of you have joined this the second open session for discussion. Already we have received 4 questions and sir will be answering the 4 and you may keep on putting questions. We are here till 7 o'clock and we will entertain the questions which will be posted. So I think
So the first question what we have received today for this live session is that LN concept and finding the L10, L90 and L50, and also there is a question on the ground attenuation concept. So those LN concept or L10, 90, 50s are come under the environmental acoustics and which is typically come under the acoustical principles which covers the statistical way. So whenever we go for any kind of a data collection in environmental acoustical point of view, maybe a noise data, maybe a roadside noise data. So we collect many samples to justify the testing or whatever for a longer duration. And when we collect a handful amount of data and those data are basically a scattered data, some data may be very high decibel level and some probably very low. So as far as the nature is concerned, it will actually follow a normal distribution. Some very small data will come under the high frequency, high decibel, and some of the will be the low. So now how to find out the what is the actual the tendency of that particular the environmental the noise. So we distribute the data in a ascending or descending order, and out of that data we divide that data into 3 subdivisions. What is L90? L90 are the divisions or the line. You can actually find out in my lecture number 37. Number of data which are actually the 90% of data which is above that particular line. So if you draw that particular line and if you see, suppose if you go to the next curve, so the 90% of the data are above that particular line, and if I draw then I get something like 21 dB is the L90. Then what is L10? The 10% of the highest level. So out of the all data you draw a line which divide your whole set of data, the 10% the higher and the 90% lower, and corresponding to that it comes around, suppose in my data set 81. So L10 is your 81, the 10% equivalent. This is 90% equivalent, and definitely 90% equivalent will be low and 10% equivalent value will be very high. And L50 is the middle, the 50% data and 50% data is top data and the 50% are the lower value of data, and you divide a line and then this is 38. So the L50 is your 38 dB. So this is the concept of the L10, L90 and L50, and further with those 3 character of the noise,
full screen. না এটা দেখতে পাচ্ছে না তো? No, are you focusing on that? Okay, it's coming. Okay.
So now it is full screen. So after you find out those 3, now there are a lot of other parameters you can find out one after another. The next question is somebody asked about the ground attenuation concept. The ground attenuation concept is that when the sound is actually propagating from one point to the other, it goes through several type of absorption, refraction and all, and also in the it is also definitely a part of the indoor acoustics, but in outdoor also it goes like that. So, ground surface, the nature of the ground surface attenuate the sound. If it is very grassy surface or bushy surface, then definitely it will be very, I mean it will be absorptive, and in the other hand if it is a very rough or not rough, but the hard surface from your landscape point of view, hard landscape and all, then it will be definitely give you more reflection. So, the attenuation is based on the barrier and the surface character of the ground, and there was no direct formula to find out that what should be the amount of attenuation. It is a matter of the taking the data and then finally finding out the what is the actual drop in dB for the attenuation or so. So, I hope these two answer was are addressed correctly, or I think you have understand that. Otherwise, you may again go through the lecture and then come back to us.
Escape করে দাও না লেটার রেফারেন্স ওখানে কিবোর্ড
So, now I will go to the next one.
এসকেপ হই যে ড্যাশবোর্ডে করো না কিবোর্ডে করো না এসকেপ কিবোর্ডে এই যে কিবোর্ডে এসকেপ মারো না
Actually, this is there.
Okay, as sir is continuing with the next question, I would like to mention that some small errors are happening as because the entire process is online and we do not have any scope to interfere in between. Even if we did not want to put anything wrong, but some unintentional errors has cropped up as stated or referred by the enrolled students. So, we will take care of that, do not bother about the marking part, we will take care as because you have pointed out or raised the mistakes, we will surely try to do a good judgment on whatever has been issues has been raised. If it is wrong, then the question is taken out of the set and the evaluation is done. I think so. The exams are on 7th of October and those who have registered are supposedly going to sit for the exams. Sir will continue with the.
So, there is a question on STC sound transmission class. The question is something like, for calculation of STC value, the steps are told lecture number 33, also after again and again it is difficult to understand. So, let us again go and let us understand. So, STC is if you go to that particular chapter that is the sound insulation. Sound insulation is depend upon lot of things, then one of the thing is that the character of the barrier, the mass density and the surface mass of the barrier. But if it is constant, suppose I am going to test a particular barrier, a particular partition wall, then it is a constant, so then it is not should not going to vary, but it will vary. It will vary because of the frequency of the sound. So, now how I am going to encounter that? So, what happened is that to encounter that particular situation, a STC contour has been plotted, and STC to plot that particular contour you have to test that particular barrier or the particular the wall. So, here in this PPT, if you see in the lecture number 33, I have mentioned that 16 frequencies which are 1/3 octave band frequency. The blue colors on the octaves and intermediate the blue, there are black colors frequencies are the 1/3 octave. So, it is a full stretch of 16 frequencies of the 1/3 octave, and you have to actually test the transmission loss of that particular the partition wall for all 16 such frequency. It is mentioned from 125 hertz to 4000 hertz. So, suppose those 16 frequency are tested, and you will get a scattered diagram like this. In x axis there are frequency, those 16 frequencies, and the y axis there are transmission loss in dB, and it will be something like this. As the frequency is higher, the dB, the transmission loss TL also will be higher. Now, from here also it is very difficult. I may get an average, but that is also not very good to take. So, what they did is that they go to the next step. In the next step, they go like, if I go to the next one, they first the last those 1, 2, 3, 4, 5, 6, these 6 frequencies, last 6 frequencies, they get the average of that 6 frequency, and they plot a straight line. See, I am actually now plotting a contour, I am equivalent contour of these plots, haphazard plots I am going to make. So, this line AB, this green line AB is nothing but the average of this 1, 2, 3, 4, 5 and 6, these 6 points. So, after I get this line, as this tendency of the other points, which is lower frequency, for this little downward. So, I will go to the next step, and in next step what I will do, I will decrease this particular slope or this particular point C, I will calculate from the point B. Point B already I got from the this average by decreasing by 5 dB. So, this is like something like a small ramp which connecting B and C having 5 dB less than this point B, and further these are also quite less. So, again I need to decrease a straight line. So, what I will do, I will decrease that C to D by another slope which is 15 dB till the point D. So, if I know the average of these 6, I can easily draw this green line, but this may or may not be the right contour, I mean right representation of this haphazard point. So, how I will know? Now, I have to see what are the deviations, what are the pluses and what are the minus. And in this particular the haphazard, you will see there are more negatives. So, in next I will find out what are the sum of the deficiencies, and all those sum of the deficiencies I will actually see that sum, if it is equal to 32 dB or not. If it is more than 32 dB, I have to rectify that contour, and if it is 32 or less than 32, I have to be happy with that contour. There is another condition is that the maximum deficiency of any one band should not exceed 8 dB. So, this is the sum is 32 and this is a particular frequency is 8 dB. So, what happened is that the deficiency will be calculated from the STC to the actual tail value, these yellow dots. So, these are the deficiency, these are the negative deficiencies. So, I have calculated and I will have to calculate, and if it is more less than that and the maximum deficiency is less than 8, it is okay. So, and that will be my first trial. So, in this particular trial, suppose I have these frequencies of those 16, I have plotted that, then this after the first trial the average 6 is 39, the last 6 is 39, and then 39 minus 5 is 34, and 34 minus 15 will be around 19 dB or so. So, this will be my green plot line in this first trial, and now I have to check the 32 and 8 conditions. This is the deficiencies. So, now I have actual minus the STC, this green line I have calculated. So, those red marks are the negative. So, I have to now add up those, I have to check that whether it is 32 or more than 32 or not, but at least I am sure that no one is minus 8 or more than that. So, the second condition is fine. So, now if I add up then it should not be less than that. Now, it is in the first trial it is 34, if you add up all it is 34. So, you have to change the pattern of the contour. So, how you will change? This is more. So, next trial what I will do, I will decrease the STC by 1 dB. So, this one 36, I will go to 37 to 36 and then again I replot everything, see it will reduced by 1 dB. So, it is 39, this is 38, everything is now 1 dB shift. So, the things is lowered down by 1 dB and again I find out the difference, and now the difference is minus 26. So, it was minus 34 in the first trial. So, I am in the second trial what I did is that I again decrease everything by 1 dB. So, now it is minus 26 and this is the maximum deficiency is 6. So, this will be the right contour. So, both criteria satisfied. So, this is the right contour, but now still the answer is left. I mean the final, what is the STC value, the equivalent, the transmission loss value as per definition. You have to draw a vertical line from 500 Hz, it will strike to that green line the actual STC contour and then draw a horizontal line. So, in the y axis it meets at 34 dB. So, I will say that the sound transmission class of the partition wall is 34 dB. Even if it shows lot of variations, something is more than 34, something is less than 34, but that particular partition wall will be designated as 34 dB STC class.
So, would you like to continue, or I have one or two questions by that time?
This is answered.
So, here we have received one question, like for auditorium, I understand angle between outermost seat in auditorium should be less than 80 degree for music and it is raised why. So, one part is experimental, other part is when you are going beyond that range, actually the lateral walls which support your lateral reflection to create that impression inside the auditorium, more you spread the lateral wall, lesser amount of side reflections you get, and automatically it reduces the effect of spatial impression, and that actually reduces the quality or the quality of the sound. And when it is particularly music where you need more of reverberation time and overlaps, there actually the spatial impression plays a important role. So, you lose on that part, and hence we give that as a binding, as we should not be playing beyond that 80 degree. Hope I could reach you. Now, coming to the resonant frequency for slit slat resonator, yes, there was a video in the error, I admit it, and that was because the constant was in inches, whereas the calculation was in millimeter. Okay. So, if you change the constant, that was 2160, which was calculated in inches, that gave that led to the error in the calculation, but if you calculate it with frequency with the constant with millimeter, then it will be, you will get correct answer. Now, noise reduction unit should be decibels and not sabine. Yes, that was also admitted. I think this was raised by some of the enrolled student, maybe one or two of the students. Yes, it was an error because the unit was not correctly given. It was given as sabine, which should have been decibel, and that might have led you to some confusion, and hopefully the answer, you could not get the answer because calculation wise it did not match, but actually it was decibel and it was not sabine. Okay. As because the unit made the confusion, I think the benefit should be going towards the students. So, those who are actually on the, who are answering these things, the assignment 3 of question 12 will get the credit. It is the system which will evaluate you. We have already shared this information with the persons who are taking care of the marks and the calculation, etc. Okay. Assignment 4 question 13, error regarding matching. Yes, that was also something inadvertent. We had again checked back to our main documents, but it somehow the other option was given as the correct answer. Hence, that led to again some error, some pointing out. We had already taken care of that again through the NPTEL officials, members. So, we had given them the directives that yes, that was a wrong, wrong alternative which was given. The correct alternative was different. I think B instead of, can you just tell, it was B, it was C instead of B, isn't it? Yes. Yeah, it was C, C was the correct option instead of B, and as because it was error from our side, we admit that, and you will be given the benefit of maybe cancelling the question or giving you marks. That is the NPTEL decision, the official's decision, and you will be marked accordingly. Here is one question I think for you. Sound energy leaves the system through both transmission and absorption. Okay, sound energy leaves the system through both transmission and absorption. Okay, as because it is basically conceptual question. So, sound within a system, whichever is our concern, say if it is within this room, then we are getting back sound which is diffused or which is getting reflected back, and some part gets absorbed where it is a loss of the sound energy, and some part moves to the other compartment or the other spaces outside. So, that is how the sound energy is getting negated. So, that was mentioned maybe somewhere. I think it is understood, whoever has raised the question, it is not much clear, through both transmission and absorption. I think that is a correct statement. Was it a statement or?
It was asked why not only absorption, why transmission?
No, transmission means there is a loss through the surface onto which it has faced, and it is leaving the system. So, it is not coming back again into the system. So, we are not accounting that which has reached the transmission loss.
They are putting live questions.
Oh, this is for the forum discussion.
Discussion for
Okay.
live questions.
Questions also coming, but they're very less.
Achha. So this is live question.
That is
That is live question, but the paper I gave you.
That is forum.
That is from the
Okay. There is a live.
okay. You can carry on.
There
Yes.
is a question came for this particular streaming session that first let me read out that how do you calculate the resultant transmission loss if the value of the surface or whatever. Achha. Then in that case can average of the transmission coefficient be calculated without considering the surface area. Okay. And also he or she has wrote like the half of the area of a partition wall having TL equal to 25 dB and other half or rest is TL equal to 50, then what is the resultant TL? So, transmission loss is calculated with a very simple formula, like again let me go to the PowerPoints, our lecture number 20, I think just a minute, 31, and let me start from the slide number 6. So, transmission loss is defined by the decibel level changes between the source and the receiver. So, Ls minus Lr. So, definitely in a particular source room somebody is shouting or somebody is actually playing a musical instrument, and the next room is the receiving room, somebody is studying. So, there is a loss because of the partition wall in between them. So, Ls generally will be or definitely will be more than Lr, and how much will be the difference between them is depend upon the character of the partition wall, and very simply it is described as Ls minus Lr. But as you know, the L, these are the logarithmic values of the sound decibel level or so. Practically this has to be changed with a sound transmission coefficient which gives you a proper indication of the transmission loss, which is actually derived by a ratio WR by WS, which is what is WR? The total sound power at the receiving room by the total sound power in the source room, and definitely this ratio also will be less than 1. So, transmission coefficient is always going to be less than 1 and transmission loss is always going to be more than 0, that is that cannot be negative. Now, I will come down to in your question that whether for calculation of the mean or average partition transmission loss, the area is required or not, or I can simply take the average value. So, you see, I cannot just calculate the transmission loss by virtue of just the transmission loss, because the logarithmic scale will put me a big difficulty. So, I have to go back to the transmission coefficient first from the different portions of the transmission loss, and I have to take a area multiplier of that, the corresponding area, and I have to take the weighted average of that. And this particular formula is also given after 2 or 3 slides. The tau average you have to calculate, where tau average is tau 1 into A 1 plus tau 2 into A 2 and tau 3 into A 3. Tau 1, 2 and 3 are the sound average transmission coefficient of the various portions of your wall, and the A 1, A 2, A 3 are the various portions of the corresponding wall. So, in your question I must say that you cannot calculate the transmission loss without considering the surface area. So, you have to consider the surface area also. Now, come down to your question that TL is 25 and TL is 50 for a partition wall, where the half is with TL 25 and half is TL 50. This is a very, very special case. Special case is that because you have both the areas are, I mean it is 50% and 50%. In that case, this particular ratio is half and half, and then it is a complete the average. So, the area effect is not coming to that. So, it is a complete average. Suppose you take the 1/3, 1/3 and 1/3, then again it is a average out. If you take 1/4, 1/4 like that 4 pieces, then it is again average. But if it is not equal, suppose a total area of a wall is 10 meter square, it is some 3 meter square is some value and then 7 is some other value, then you cannot take the average. But if it is a 3.33, another 3.33 and another 3.33 are having 3 different value, you can take the average. So, those are the special cases where this area, total area and the subdivision of the area is in a similar or the equal divisions or so. So, in your finally, so you finally find out the what are the tau 1 and tau 2 and find out what is the tau average, and from the tau average you go back to the tau TL with the help of this formula and or maybe the formula which is this formula like this TL is equal to 10 log 1 upon tau. So, you got the this tau value and then just put this one and find out the TL, the average TL. So, that was the live question on TL. Anything live questions is there for me?
We have another live question. In site planning, the wind direction also plays a role in noise sensitive zone. The wind may cause noise to blow from noisy zone to noise sensitive zone. I think this is a question from Rohit Garg, and yes, Rohit, you are right. I think this is a statement, it is not a question, and we have discussed earlier also, like we take help of wind direction while we take help of sending the sound or the signal towards the audience taking help of the wind direction. In case of OAT we have done, and we have also seen historically it was practiced during the Greek or the Roman times. So, what was your concern is in site planning, yes, we need to consider the wind direction also if there is a noisy zone and we do not want the noise to come towards the site, then we have to either guard it and take care of it, or we have to orient the building, entry, etc., so that it does not, the noise does not affect the site planning. So, we acoustically we can actually consider it while planning, it is right as you have raised. And particularly in case of hospital, particularly in case of school, we need to consider this important point. And yes, I think it was also discussed in the introduction lecture at some point, maybe not with reference to wind direction and the noise coming into the site, but with reference that we need to take care of noisy areas, so that the quiet area is remaining quiet, and wind direction do have a part in that. Is there any more question? Okay. From the forum we had another question, why flooring is not considered while calculating absorption, like that was for developing the curve. That was for developing the curve when we have different, when the volume is increasing, whether to cover the ceiling is better or whether to cover the wall is better. So, in that case we did not consider the floor, because floor usually gets occupied with the furniture, and if it is not told like having carpet etc., otherwise we keep the floor as a reflecting material, because it is hard surface onto which we bring in the furniture which requires movement, shifting, and it's the furniture's absorption coefficient etc. are considered when we are really doing acoustical design. So, in that case the floor is not considered when we are developing the curve for a particular volume, when we are trying to see how the variation takes place with covering the ceiling and maybe covering the walls, or maybe a comparative study which is more effective, what to do when we are getting the walls and the ceiling to get as the acoustical treatment areas. I hope you whoever had raised the question has been already answered through the forum, but now I think it is openly discussed, so that all of you can have the clarification if you still have some question in mind. Would you like to add something, or do you have a question? Forum question, okay.
That I will answer. And
okay, so
see, there are some forum questions. The first one is what is the difference between the source and signal. See, actually the signal comes from the source. Source of a noise or maybe a source of a sound is a particular instrument which generate the noise and then or sound, and when it is propagate we call it as a signal. And there are actually we say it is a signal and in the noise. In case of electroacoustics, signals are welcome, always we welcome the signal which is comes for any kind of a electroacoustical magnification or whatever. But there are some noise also which has to be we have to make the shadow of that, and there should be a considerable amount of difference in dB level between the signal and the noise. So, that was the first question. The second question was, can transmission loss become negative? So, just now I have answered, no, it cannot become negative, because it is from the source room. If something is there, definitely in the receiving room either it will be same if there is no partition wall, or it will decrease. So, it cannot be negative. Then the third question was the details of impact insulation class, IIC. Impact insulation class is also derived in a very same manner as the STC, the sound transmission class is derived, very similar manner. and as you remember that the impact insulation class, instead of generating some sound, a impact noise is generated. And from that point of view, again that 16 1/3 octave band is considered, and very similar manner they calculate the impact insulation class. As we have not go into very detail of that, because as it is very similar, and number 2 is that it is practically used for mechanical vibration control, and mostly for the mechanical engineers in the shop floor and all other areas. So, we thought it will be bit of out of the scope of our curriculum or course. Then the last question was what is noise climate and how to define how to find it. It is clearly given in one of the lectures, definitely either 37 or 38. Noise climate is a is again a parameter from which you can justify and you can actually rate a particular area. And as you know, if you take a total day long or maybe 6 hours or maybe 2 hours data for a noise in a roadside or maybe industrial power plant or maybe near airport, there will be fluctuation of the noise. And sometimes it is less noisy, and in sometimes it is the very noisy. It is not going to be constant. So, you have to select the data. I mean, if you take the data after each 15 minutes or maybe half an hour, you will select lot of data, and from that data you generate L10, L50 and L90. And noise climate is the difference between the L10 and L90. That means the highest expected level and the lowest expected level of the noise, and what is the difference in that. So, that is the actually the concept of the noise climate. And that the way it is find out is L10 minus L90. So, you have to considerably see the data. Suppose if you want to find out the noise climate of a road, so definitely you have to take the data in the busiest time, maybe in the morning 9 o'clock to 11 o'clock or something like that, or evening time. If you want to find out it is in airport, it is you have to see the what is the timing, and then if it is a very busy airport, you have to take day long. And suppose it is industrial shade or something, then you have to take the data for 8 hours or some of the time. So, you have to select those time and then find out the what is the peak and the saddle point, and by L10 and L90.
I think we do not have any more questions till now. So, there was a confusion regarding absorption in humid air and dry air. Actually, with change of humidity or increase in humidity, more absorption, when humidity is more, absorption is less, but this is when humid condition prevails. But for dry air, it has less absorption. That is experimentally derived, and there are curves which has been shared in the forum. This is from the forum, and it has been, the answer has been actually shared in the forum. So, you can see the curves. It has not been put in the PPT. We cannot put it from here, isn't it? So, you can look into the forum where the curves are given. So, dry air is a special case where there is no humidity, and that has been treated, that is taken separately. And with humidity it is changing, that is with humidity the pattern changes. So, do not get confused on that. Okay, regarding the exams, I think there are two exams in the same day. One is the forenoon session and the other is the afternoon session, and there are 2 sets of question papers also made, and hopefully we have tried to make it error free. Hopefully, you will not encounter any kind of problem over there, and you are always free to contact if you feel there is any anomaly or maybe points which need clarification. We are there to take care of it.
Okay, let me say something.
Yeah. Would you like to? Yes.
The first of all, do not be in panic in the examination. Everything will be the questions are within that our 40 lectures, and there are questions which is very easy, there are questions that are bit tough, and there are some question definitely 2 or 3 will be a little bit of you have to think and write. So, there is nothing like a very tough and a tougher kind of a question. That is number one. And another thing I should say, I think it is almost end of our live sessions today, and this is the last time to chance to get to interact with you. There is a feedback also, probably the NPTEL will give send you for some kind of a feedback. So, I have 2 points to tell in that feedback. The number one is that whatever you really justify yourself about this particular course, please write down. If it is good, do not write bad. If it is bad, do not write good. Whatever is the thing, you should write, number one. And if it is, there are definitely something is lacking, and this is our first course. So, you give some suggestive improvement in the areas where you can definitely improve in the next time. And if there is, I do not know what are the format of the feedback, definitely there are some points and all, and if there is something you can type and all. So, you can also write down something like, is it from the live session?
No, it is not a question.
So, in that which other subjects you want this NPTEL lecture, in which other subjects you love to have those kind of a lectures, then we can initiate with us, or maybe with some of our other faculties we can actually initiate, because I hope everybody are from the architecture background.
Most of them, I think civil definitely. Engineering is also there.
Please remember these 2-3 points in the feedback, give right feedback, give suggestive improvement feedback, and give some areas where you like to have the NPTEL course.
Okay, I think I would add some technical things on along with what sir told. That was the evaluation part or feedback part. On some instructions for the examination, online scientific calculator will be given. So, you need not carry your calculator yourself. Any data, constant, etc. will be given alongside the exam question. So, it will be included in the question. So, you need not need to require to refer something, but for formula you have to memorize and come to the exam. So, whatever small calculations will be there, you have to do it just from the formula which was already given. So, please go through the formula, and that would be helpful, because you will have to face some small problems, you have to work it out, and do not get just leave it like that. You try try to attempt those. Okay. And I would wish you all the best, but at the same time I would bring to your notice two assistants, Vishwanath Bosak and Arpan Pal Singh, who are doing PhD over here, assisted us throughout the last few months to bring success to this particular course. So, they were interacting with both of you. I think Arpan, you say hi, just Vishwanath is there. So, they were, one is having civil engineering background, and Vishwanath Bosak, he is having architecture as background. So, you can understand they also took interest, maybe they also learnt, and we also learnt and enjoyed actually how to prepare this kind of course, and it was really interesting. I hope we could reach you to some extent, and the feedbacks we will try to improve ourselves. Hopefully, we are not perfect. At the same time, I again feel sorry for the small assignment mistakes which we had were committed, whatever be the reason, which was not at all our intention, but we had come across 2 mistakes which were pointed out by you. Thanks for that. So, wish you all the best, and I think, do we have anything more? Okay. So, do we